Good evening, Year 8 Science students again. It's Mrs. Conway again. This is Lesson 6, Metamorphic Rocks. We're just slowing it down again. So this is the last of the rock cycles that we're going to look at, the metamorphic rocks and how they develop. All right, so describing the following term, what is a fossil, what is a clast? Okay, so a fossil is a preserved remains of living organisms found in a rock and soil. A clast is a fragment of clastic rock, so it's just broken down pieces of rocks that are weathered away. Okay, lesson 6, metamorphic rocks. All rocks can be altered by heat and or pressure to form metamorphic rock. This process turns ordinary limestone into beautiful marble and soft sandstone into hard quartzite. Lesson intent, understand the process of metamorphic rock formation, classify metamorphic rock samples and their parent rocks. So these are the spelling words: contact metamorphism, dynamic metamorphism, foliation, metamorphic rocks, regional metamorphism, tectonic plates. So the success criteria will be describe processes involved in the formation of the metamorphic rocks, identify types of metamorphic rocks, and make links to their parent rocks. The lesson sequence is going to be review for rock formation process, define metamorphic rocks, model the formation of metamorphic rocks, and describe structure and types of metamorphic rocks. The metamorphic rocks form when intense heat and or pressure alters existing rocks. So physical changes, the folding of the rock, folding the rocks or sliding different parts of the rock sideways in the process called shearing. Heat and pressure can cause chemical changes such as recrystallization of minerals. In the top right corner is a garnet gemstone, and that's an example of a significant metamorphic rock. As rocks bury deeper, the temperature and the pressure increases. Movement of the Earth's crust or massive plates called tectonic plates. That's what's the tectonic plates are floating around or moving around on the mantle, and they can collide, they can pull apart, and they can scrape past each other. And in that process, that's when metamorphism occurs. So metamorphism occurs because the range of the temperature and the pressure results in a variety of different types of rocks. So there's three types of metamorphism. There's regional metamorphism, which is both the rock is altered by both heat and pressure. And it's usually a large area has had this change and it's resulting of colliding plates or rocks being buried. Now, number two is contact metamorphism. This is where the rock has been altered only by heat. And it's usually in small pockets and it's a result of hot magma intruding into the rock. Okay, or dynamic, number three, dynamic metamorphism is a rock altered by pressure. Small area where the crustal rocks are scraping past each other. So only pressure, because you think if you collision, so using your hands like tectonic places, if you remember, dynamic means that you're just pushing past each other. Contact is when the heat has come through and you can feel that heat. And regional is both heat and pressure. So they're the differences between the types of metamorphism. As this is going, I'm going to play my blooper song, and there's going to be stopping and starting of it, and you've got to try and pick up what song it is. All right, so there's some start. This is a diagram of metamorphic rocks and the three main ways it's done. So you've got the regional, which is represented as an R, and that's always happening between plates colliding with each other because there's heat and pressure. And then the contact metamorphism is straight up at the top, and it's usually just around volcanoes, and their contact is because it's only heat. Dynamic is where there's pressure, so that's only when it's in a small area, so you can just see the small d just up near the top, and only small amount of pressure has moved. All right, metamorphic change. So the texture changes and it can become foliated. Foliation is the movement of minerals into layer or bands. So as you can see in these pictures beside that beautiful black and white one is a distinct foliated metamorphic rock. And you can see slight colorations that are just a little bit less easy to see with a little bit of green and brown and a little bit of grey. And it's that folding look within the rock. The pressure can squash and crumble layers of bands, making them wavy. Not all metamorphic rocks are foliated. Example, diamonds are gemstones that can be formed in metamorphic rocks when part of the crust becomes pushed into the mantle. The crust sinks to the depths of about 1,500 kilometers, where high temperature and pressure causes the change. If the temperature is over 1,000 degrees Celsius, the carbon then can crystallize into diamonds. So that's how the process of diamonds occurs. Now, marble is as an unbanded, non-foliated metamorphic rock, and same with quartzite. So, quartzites. So those are the images there. You may have seen a few of them in your travels. Have a look at your rock, see if it is foliated. That's one way of checking if it's a metamorphic rock. Now, going back over the rock cycle, as we know, we've talked about igneous rocks, we've talked about sedimentary rocks, and now we've talked about metamorphic rocks. We need to know the rock cycle in and out and how it works. So igneous rocks comes from the magma. Then if it's extrusive, that's where the lava is outside and it cools down very quickly. Magma ones, it has large crystals, and it's the crystallization and melting process that's in. Over time, the weathering of these igneous rocks and erosion or deposition makes them into sediments, and that sediments is just a collection of fragmented rocks. This can be compacted and cemented together. So remember, you can have water going away and it's like cementing when you have little fragments within it. So that's when we call it sedimentary rocks. Those can then weather and go back to that cycle again and go back to sediments. But it moves on to the next press when it has intense pressure and heat, or either it melts down when it gets further into the earth and goes back into magma. Now, intense heat and pressure change it into a metamorphic rock. So the sedimentary rocks can sometimes change the metamorphic rocks, and same with igneous rocks. If it goes back under intense heat and pressure, it can change into a metamorphic rock. Now, most of these processes you can see is weathering, erosion, deposition, compaction and cementation, melting, crystallization, metamorphosis. So you need to know each one of these processes. We've gone over them in detail of each stage, but this is putting it all together now into the rock cycle, and this is what your exam's going to be on. So your homework. So hopefully I'll give you the blooper again to see if you can pick up what it is. You have to think of the name of the song and who sings it. So as we know, we're talking about rocks, so it's always going to be related. So the blooper of this week, make sure you have a look, and hopefully if you pick it up quickly, there was a few chances there where you could have got it right. So homework, we're going to think of metamorphic rocks. There is an example of melting chocolates and putting different types of chocolates with different flavoring in it, and you can get different types. And that is an example of metamorphism. Now we're going to practice for the exam on the rock that's coming up. This is the review questions. Just have to get as many as you can done. If you can't do all of it, that's okay. I know it's a lot. 17 questions is a lot, but just see how much you can get done because it's good practice for the exam. And then in the last thing is identify any metamorphic rocks that you see in your rock sample or your rock collection. So that is the end of week 5, and you should be done with online learning. Thank you very much.